Am I audible to all of you? Hello. If you can hear me, okay. Can you hear me now? Uh, am I audible now? Hello.
Yes, sir.
Okay, that's great. Also, Priyanka, I have given you the link for the backend in the private chat. You can click on that and join the Google Meet. Okay, so those of you are joining, those of you are joining right now, just a second. Sorry. Okay, so here we go. Okay, so I see Divyessh Maheshwari is joining. Uh, that's great. And many other people you are joining here. That's great. We have a decent audience now. So those of you are joining right now, we will be doing some really exciting mathematics today. And the way we will do it is from the toppers of our previous month, the Math Olympiad program at Cheenta. So we have with us Vishal. Hello, Vishal. Can you introduce a little bit about yourself? And then
I'm Vijay Kumar from 6th standard.
okay, where are you from, Vishal?
I'm from Bangalore.
Oh, they are saying that they cannot hear you. Let me see.
Hello?
Yeah, there's some reason they cannot hear you actually. Mm, can people not hear Vishal? Okay. Vishal, can you switch on your audio? Hello.
Hello?
Yes. Yes, yes. I think people can hear us. Yes, they can hear you. Okay, great. So, those of you who are joining in, I will ask you to please switch on your videos and audio so that we can all see and hear each other. We will be, that's great. Okay. So, we have a vision where um, this is an idea that we will be implementing in the year of 2000 and okay, year of 2021, where the best students of Chinta will be given an opportunity to teach other kids in Chinta. So I will be extending that offer to most, if not all of you. But before that, let's see some of it today. So first we have Vishal. Vishal is in sixth grade. Where are you from, Vishal? You were saying that, and then the thing was cut in.
Sir, I'm from Bangalore.
You're from Bangalore, Vishal. Okay, so you are in which level in Chinta?
Level 2A.
Level 2. Okay, so he is in the Math Olympiad beginner program, I think. So go ahead, Vishal. Show us your. So he is the level 2 topper from Chinta the last month. So can you share us your mathematics, whatever mathematics you want to share with us? So this is how we will do it. The
Sir,
students who
can I
have,
present a video?
yeah, you please go ahead and present it. But
Yes, sir. This one, please.
and we have with us Shabitri Nanda. Hello, Shabitri. Can you tell us a little bit about yourself?
Well, it's Priyanka.
Oh, okay, Priyanka. Okay, fine, Priyanka. Which class are you in, and which level of Chinta are you in?
Well, I'm in seventh grade and I'm in level one.
You are in level 1. Okay, that's great.
Right.
And we also have Divyesh with us. Divyesh, which class are you in and which level of Cheenta are you in right now?
Good evening, sir. I am in class 10th and level 5.
Okay, level 5. Okay, that's great. Oh, level 5. So that's awesome. He's among the seniors. Okay. Dr. Dhobale, I'll just email you the link. Uh, uh, just a second. Yeah, so that's great. Divyessh, he is the level 5 topper. That's not a small feat. There are very good students in level 5 and obviously in level 1, 2, and 1 as well. So, Divyessh, are you ready? Vishal, are you ready with your presentation or what's going on there? Okay, I can barely hear you. Almost I cannot hear you actually. Shabitri, Priyanka, are you ready with your presentation? Do you have it with you?
Yes, sir, I have.
Okay, great. So, okay, I can see Vishal's presentation now. So, go ahead, Vishal. We can see your screen. Why don't you tell us what exciting mathematics you have in store with us, store for us? Go ahead.
Hello everyone. I'm Dr. Vijay Kumar from level 2 of Cheenta. Today, I'm going to present a prediction of some basic mathematical formulae which I learned from Cheenta. The first formula that I've taken is a plus b the whole square equals a square plus 2ab plus b square. I just want to make an assumption that a is greater than b in this case. The square of a value can be geometrically related to the area of a square shape having side a. As we all know, the area of square is a into a equals a square. Similarly, another square of side b has an area b square. Now, a bigger square which has the side of a plus b would have the area of a plus b the whole square. To understand the constituents of a plus b the whole square, let us break it in terms of square a and square b. The area of a plus b the whole square is the sum of the area of square a, square b, and the two rectangular strips having sides a and b, which is a square plus b square plus ab, which is equal to a square plus 2ab plus b square. So this is how you interpret the basic formula of a plus b the whole square in terms of geometric objects. This was pretty simple to visualize, so now let's go a bit further. We will now see how to interpret a minus b the whole square. I'm again assuming that a is greater than b. You can see that a square is represented in terms of the area of a square object. Similarly, we see a smaller square of side b representing b square in terms of its area. To prove a minus b the whole square equals a square minus 2ab plus b square, we visualize a minus b as a smaller square within the square of side a. The area enclosed by square a minus b is nothing but the area of square a minus the area of the rectangular strips of length a and width b. As there is overlapping area of b square from the smaller square formed by the rectangular strips, we have to subtract it just once. To compensate, we add up b square to get a square minus ab minus ab plus b square equals a square minus 2ab plus b square. A similar interpretation can be applied to many other basic formulae like a square minus b square and a cube minus b cube and so on. Thank you for giving me this opportunity.
This is fantastic. That's I really liked what you did, Vishal. Of course, this is one of the beautiful parts of mathematics that we often discuss. There is a connection between geometry and algebra, and that interconnection between geometry and algebra is a very important component of solving interesting problems. I just remembered, and I want you to look into this, Vishal, and others who are watching this. There is a connection between platonic solids, the three-dimensional solids that are out there, and elementary number theory. There is a book called Excursions into Mathematics, and I'll put that in the Excursions into Mathematics. Uh, this is a very beautiful book. You can find it online. And in this particular book, you can actually uh, look into this connection between geometry and algebra in more detail. Excellent work, Vishal. So, congratulations to you for explaining mathematics in such a beautiful way. I must say that I also loved your presentation. It is an amazing presentation. You created all those beautiful animations and you really took time to do this. So, this is awesome. Congratulations. Make sure to send us your address. The Cheenta admin will get in touch with you regarding that so that we can forward the prize for that month. Okay, next we will have who is going to go next? We have Divyessh. Do you want to go next?
Um, Actually, sir, I have not prepared any presentation.
Okay, that's fine. Do you want to share with us something a little bit about beautiful mathematics? Anything that you think in particular will be really interesting for us to hear? Some problem that you solved
My
recently?
my favorite topic in mathematics is the number theory.
Okay.
So maybe I'll share the three main number theory theorems: the Euler's, Fermat's, and the Wilson's.
You can share only one. That's also fine. Share. Tell us a
Okay,
little
that
bit
will be
about
great.
one
So
of
I'll
your
be
favorite.
sharing the Euler's.
Okay, go ahead.
Yeah, that's great. So Euler's theorem says that if n is any positive integer
Okay.
and a is prime to n, prime or co-prime to n, then a raised to power 5 of n is equal to 1 with respect to mod of n. This is
Okay.
actually a very nice theorem because even the Fermat's theorem is also a special case of this theorem only, in which the a is a prime and everything else
Okay.
is same.
So those who do not know what Divyessh is talking about, there was a very famous mathematician called Leonard Euler, and I don't know if you know this, that Euler went blind for a good part of his life. He was a Swiss mathematician. He was from Switzerland, but he went to Russian Academy of Science, and then he worked there for a considerable amount of time. But when he was working there, he was blind for a large period of time of his time there. But he was still doing mathematics, so he was dictating stuff and other people was writing down his whatever he was saying, and that was the one of some of the best mathematics that has been ever produced. So Divyesh is actually telling us about one such theorem by Leonard Euler from elementary number theory, and the theorem that he's referring to is related to Euler's phi function. Phi function basically counts the number of numbers less than a number, let's say 10. You look at the number 10 and you look at all the numbers which are less than 10 and whose HCF or GCD with 10 is 1. All the numbers less than 10 whose GCD with 10 is 1. So Euler's function basically counts those numbers. Now those who are are a little bit adult and have seen group theory, they know that Euler's function has tremendous connection with group theory. It actually counts a special type of group, um, which is basically derived from the cyclic groups again. So anyway, excellent work, Divyesh. Thank you for letting us know so many things. Congratulations, and send us your address as well. The Cheenta admin will get in touch with you. Okay, Divyesh is the level 5 topper. Awesome work. Okay, next we have Priyanka and others as well. So Priyanka and Sarthak, who Priyanka, you'll go first. Okay, go ahead.
Yes, sir, sure.
Priyanka, is
Okay,
you're
let
in
me.
which class right now, Priyanka?
Sir, seventh.
class 7. Priyanka is in class 7. Okay. So she is another topper. Where are you from, Priyanka?
Sir Bhuvneshwar.
Priyanka is from Bhubaneswar, Odisha. Okay, fantastic. Go ahead. You can share your screen with us.
Yeah, sure. Just a second.
So, those of you who are joining right now, you are with some young mathematicians who are learning beautiful mathematics and explaining to us what they have learned and what they are thinking about the things that they have learned. It's a very exciting thing for all of us because we teachers often do mathematics in class and just exit. But what if we let the students do a little bit of mathematics? Go ahead, Priyanka. Why don't you share us what you want to share?
Just a second. It's taking time to
Okay,
load.
that's fine. Take it. Yeah, that's fine.
Yeah. Uh, Sir, can you see?
I can see the screen that you have shared, which is the Google Meet. I cannot see
Okay, cool.
the. Yeah, yeah. Now I can see
Yeah,
it. Okay, I can see your presentation. Why don't you click on slides and start sharing?
yeah.
Okay. Wow,
There.
this is looking really nice already. Go ahead.
Well,
But
actually, I wanted to present it, but I'm not
yeah,
able to. Okay,
no, this
now
is
I'm
fine.
able
Yeah.
to.
Okay, so you're telling us about
Okay.
geometry. Go ahead.
Yeah, right. So, geometry is a branch of mathematics that studies the sizes, shapes, and position, angles, and dimensions of things. The word geometry is derived from the Greek word geo, meaning earth, and metri, meaning measurement. There are three types of geometry: Euclidean, spherical, and hyperbolic. Okay, so that's it. And yeah, early geometry. The earliest recorded beginnings of geometry can be traced to Mesopotamia and Egypt in 2nd millennium BC. Early geometry was a collection of empirically discovered principles concerning lengths, angles, areas, and volumes, which are developed to meet some practical need in surveying, construction, astronomy, and various crafts. So this is a picture of an Egyptian and in Mesopotamian mathematicians performing geometry.
Okay.
Mm, History. Euclid was a great mathematician and often called the father of geometry. Euclid of Alexandria, probably a student at Academy founded by Plato, wrote a treatise in 13 books, actually chapters, titled The Elements of Geometry, in which he presented geometry in an ideal axiomatic form, which came to be known as Euclidean geometry. So this is a picture of Euclid, I mean.
Okay. Well, supposedly.
Yeah, it's Euclid, sorry. Yeah, geometry is a, okay, wait. It again came, okay. So flat like squares, circles, and triangles are part of flat geometry and are called 2D shapes. These shapes have only the length and the width. Examples of 2D shapes are in flat geometry are circle, triangle, square, and rectangle. Solid shapes are also known as 3D objects having the third dimension of height or depth. Example of 3D shapes in solid geometry are cube, cuboid, sphere, and cone. Two-dimensional shapes. In geometry, a two-dimensional shape can be defined as a flat plane, figure, or a shape that has two dimensions, length and the width. Two-dimensional or 2D shapes do not have any thickness and can be measured in only two faces. A point is zero-dimensional while a line segment is one-dimensional. For we can only measure its length. Three-dimensional shape. The attributes of a three-dimensional figure are faces, edges, and vertices. The three dimensions compose the edges of a 3D geometric shape. A cube, rectangular prism, sphere, cone, and cylinder are the basic three-dimensional shapes we see around us. So these are three-dimensional shapes. And then these are some common three-dimensional shapes which we see around us. Cube, there's a Rubik's cube and a dice. Rectangular prism, there's a gift box and a book. Sphere, there's a globe and a ball. Cone, there's a carrot and ice cream cone. Cylinder, it's a bucket and a barrel. And so these are the names of 3D shapes, picture, and attributes. The
Excellent.
cube
So I
has
think you have run out of your time, Priyanka, but very good, very well done. So I would say that we can save some of this for the internal seminars as well. But excellent work. I must commend you on your great performance. And we love the fact that you topped your batch. So please um, do send us your address so that we can send out the prize as well. Okay. All right. You can
yes,
stop sharing this particular screen. Thank you. Let us move on to the last person in our group, who is Sarthak. Sarthak, do you have anything to say to us? You are in
Yes.
which
I
group?
am level 2.
Level
Start.
2. Okay, go ahead, Sarthak.
Yes, I'm in it.
You are in 8th grade. Sure.
Yes.
So those of you who are joining right now, you are watching some of our students doing some beautiful mathematics, explaining to all of us, especially they are the toppers of their batch in the previous month. We plan to do this every month. Priyanka, awesome job. Really, we loved the way you did it. And of course, Divyessh and others as well. Okay, so we have Sarthak's screen. I can see your screen, Sarthak. Now, if you want to go to a specific, whatever you want to go to, I can see your screen, entire screen, Sarthak.
Can you hear it?
Yeah, I can see your screen, but I cannot see a presentation.
Wait. Wait.
For example, I see your Google Chrome actually. Okay,
So now can
now I can see it. Yes, great.
wait. Wait.
Okay, so this is seems a exciting topic, infinite descent. So we can see it, Sarthak. Go ahead.
Actually, it's recorded.
Okay, fine. But we cannot hear you. Your recording.
Wait.
You can tell us actually what you have, Sarthak.
Yes, sir. So,
You can just share the
so like,
PPT and yeah, share it with us.
okay.
Because infinite descent is a very beautiful topic. Those of you have not seen this
Yes, sir.
before. It's an amazing topic. It's a heuristic rather, and Sarthak is going to tell us a lot about it. So
So, sir, it's yeah.
yeah, I can hear you.
Yes, sir. So,
Like you can
so
go
like
to you can go
first,
to the first slide. What's the problem?
yes, sir. Yes, sir. So the first we start with the statement of principle of infinite descent.
Okay.
Like the statement is really trivial, but it's very powerful and used to prove some very good theorem like format proof.
the theorem like x to the power 4 plus y to the power 4 equals to z square has no integer solution.
Okay.
So it can be used to prove some very good theorems. So like basis of this method is simple, that we cannot have an infinite decreasing collection of positive integers. Means like we cannot find a sequence which is in infinite descent of positive
Okay.
integers.
So it cannot forever go down in value and yet have an infinite many numbers there, because there are only downward it is sort of bounded by zero. Below zero
Yes,
it's negative numbers. Okay, go ahead.
yes, sir. So the question I have, wait. So the question is, find all pair of positive integers that satisfy the equation a square minus 2b square equals to 0.
Okay.
So like the solution is, so like suppose there the existent positive integer solution
Okay.
such that a square minus 2b square equals to 0.
Uh-huh.
That pair be a1 b1.
Okay.
So a1 square would mine equals to 2b1 square.
Okay.
This implies that a1 square will be an even number, and which will further imply that a1 will be even number.
Okay.
So a1 is an even number, so a1 would be 2a2 for some positive integer a2.
Right.
Now we like again substitute the value of new value of a1 which we got in the original equation,
Uh-huh.
and we get 2a2 square minus b1 square equals to 0.
Okay.
So therefore from there we get that b1 square is even, and this implies that b1 is also even.
Uh-huh.
Hello?
Yeah, I can hear you. Yes, we all can hear you. Go ahead.
So as b1 is even, like we can substitute b1 as 2b2, and then again substitute this in the equation a1 square minus 2b1 square equals to 0.
Uh-huh.
So by substituting it, we get another pair of solutions a2 square minus 2b2 square equals to 0.
Right.
And that pair of solution is smaller because a1 equals to 2a2. So
Right.
and they both are positive integers. So we have a1 greater than a2. And then similarly we have a1 greater than a b1 greater than a2 greater than b2. So like similarly we can same process for a2, then we will get a3 b3, and then it will continue up till infinity. But this contradicts the principle of infinite descent, that the natural numbers are in infinite descent, because we assume that the all solutions are natural numbers. Like so
Outstanding.
there are no pairs of natural numbers that satisfy this equation.
Excellent. Very good. Very good. I mean, what Sarthak told us is actually one of the most amazing pieces of mathematics that is out there. Maybe you have seen it before, maybe not. What you really do is you show that if there is one solution, if there exists even one solution to a problem, then you can find an infinite sequence of numbers, all getting whose value is getting down and down and down, and they're all positive. And that is a contradiction, because that cannot happen. That's basically infinite descent. Okay, fantastic work, Sarthak. You can send us your address
Thank
as
you,
well.
sir.
We will be definitely sending out the prize. So thank you everyone for attending, and those who listen to it, thank you for listening. We will keep on doing great mathematics and do some very interesting things this year. So stick with us, and we will see you in the next meet. Bye. Take care.